All right, I'm going to do a short video here to answer a few of the questions some of you have had on the Chapter 7 review. The first question I had is on number 18. Number 18 says 3x all to the 0 power over 2a. And this one's actually a pretty simple one. If we remember one thing about this part on the top, and more specifically, if you remember about anything to the 0 power. Anything to the 0 power is always 1. That means this whole portion on the top just becomes 1. And there's nothing else happening to the bottom. So it just stays 1 over 2a. So as long as we remembered that anything to the 0 power is 1, as long as we remembered that, this one is pretty simple. Something like number 22. I'm going to make up a different one, but it'll be kind of like number 22. Again, this is not 22, but this is an example that is like 22. Maybe I'm going to say negative 7 x to the 5th, y to the 7th, z to the 6th over negative 35 x squared y cubed z to the 5th. Now remember, we can deal with these numbers just how you normally would in a fraction. A negative 7 and a negative 35. Negative over negative is going to make my new answer positive, so I don't got to worry about my negatives anymore. And I'm going to reduce 7 over 35, and I know that that's going to be 1/5. Now to deal with these exponents, when I'm looking at the x variable, I have 5 and 2. And if you remember, when I'm doing division with exponents, I have to subtract. So 5 minus 2 leaves me x to the 3rd. And because x to the 3rd, that third power is a positive number, it stays up on top where it is. Y to the 7th and 3rd. So 7 minus 3, y to the 4th. And now when I get to the z's, 6 minus 5 is just 1, z to the 1st, or just z. I could leave my answer just like this. This would be acceptable. Or I could get rid of this 1 on the top. I don't really need it there, but it's not wrong to have it there. But I could also write it like this. So if you follow along with that, 22 should be pretty simple for you to do. 32, I think you might just be a little confused on how you're actually supposed to get that answer. You're just supposed to put that in a calculator and find out what it tells you. But make sure, like I've told you before, you're careful when you enter it into the calculator. We do our number, 32, caret key, that up arrow key. And then I would use parentheses again, and then put that fraction in, 2/5. 2 divided by 5, end parenthesis, and then hit equals or enter or whatever button your calculator has. I'm just going to check this real quick to make sure I get it right. (32) to the, oh no, never mind. I'll figure that out later. But if you put this in your calculator, you're going to find the answer you need. And that's that. 36. I'm not really worried about 36. We didn't really go over some of these. I'll just show you how it would be done. But like I said, we haven't done any examples like this, so I wouldn't expect you to be able to do this on a quiz or a test. 4 to the 4x minus 1 equals 32. And we're trying to find out what value for x makes this true. We want to get these bases. 4 is my base and 32 is my base. I want to get those to the same number. So if this 4 over here, if that's a 4, I want this to be a 4. But 4 to any power, I don't think any of those give me 32, because 4 times 4 is 16 times 4 is 64. So that's not going to work. Let's just take a guess here and say, well, what if I change this to 2 to some power? Can I get a 32 that way? So 2 times 2 is 4, times 2 is 6. No, it's not. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Right there. That was the 5th time. So 2 to the 5th power is the same as 32. So if I have a 2 here as my base, I need a 2 over here as my base. Well, that's a lot easier. 2 to the 2nd power gives me the 4 that I was needing. And I still have this 4x minus 1. That just comes down and stays in the exponent with me. So now that I have the same base here and here, I can just take this exponent portion and make it equal to each other. 4x minus 1 in parentheses with the 2 still equals 5. I'm going to do the distributive property here. 8x minus 2 equals 5. Add the 2, add the 2. I'm going to shrink this up a little bit. 8x equals 7. Divide by 8. Okay. So it's not that difficult. It's just that we haven't really gone over those before. 38. Number 38. I'll do an example somewhat similar to 38. Let me think of something here. Maybe something like 27 x to the 3rd y to the 6th. So if we're looking at this, we're trying to simplify this, break it down into its easier parts. And remember, we look at this number and we're thinking about that perfect square list. If you remember when we did these on the board. 27 is divisible by 9, and 9 is one of my perfect squares. 9 times 3. And I still have x to the 3rd, y to the 6th. We know the square root of 9 is 3, so I can pull that 3 out in front. And now we're going to work with these variables. So we know I have a 3 out in front, and I still have my 3 on the inside. And remember, we can take pairs of exponents out. So if I have x to the 3rd, I can take out one pair, and that leaves me with 1 in here still, because I can take a pair out. So I took 2 from here, and it becomes 1 out here. So that took care of 2 of these, and I have 1 left. So I've got the 1 left in there. Now y to the 6, that's an even one, so I can take out 3 pairs of y's. So I'm taking out y to the 3rd power. And there's none left inside because I took all 6 out. So that would be the final answer for that. 3xy cubed times the square root of 3x. So 38 will be very similar to that. And 44, the last one I'm going to work on with you here for tonight. 44. Let's just say the square root of 1/2 times the square root of 3/5. Well, when we multiply these, we just multiply straight across. 1 times 3 is 3. 2 times 5 is 10. So it's the square root of 3/10, which really means the square root of 3 over the square root of 10. But if you remember from before, we can't have a radical symbol in our denominator. The radical symbol is this square root symbol, if you remember. Can't have that in the bottom of a fraction. So if you remember, we had to rationalize the denominator. That means I'm going to take square root of 3 over the square root of 10. I'm going to multiply it by root 10 over root 10. And when I do this, square root of 10 times square root of 10, that's just 10, because it's the square root of 100, and the square root of 100 is 10. And then 3 times 10 is the square root of 30. 30 is not divisible by 4, not divisible by 9, not by 16. So I can't simplify this any further, so I'm finished right there. So number 44, again, this is not exactly 44. It's a problem very similar to it. You should be able to figure it out and get to the answer. Hope that helps out some. If you guys need more help, just shoot me a comment on the Google Classroom, or you can email me, however it is you want to do that, and I'll help you out some more.